All right, so yesterday we went through how to solve and evaluate logs, some of them using lasso method and some of them using BAP. Today we are going to be expanding and condensing logs. Remember that logarithms are just the inverse of exponentials. And so just like exponents, as long as they have the same base, you are able to expand or condense logs as long as they have the same base. So to recall, exponent rules, when I am multiplying, we know that we can add our exponents. So a lot of times we associate with exponents, multiplying means to add. A lot of times when we are dividing our exponent rules, we know that we can subtract our exponents. So we have that association already in our minds. So when we are trying to expand logs and we see two items inside of the log that are being multiplied, we can expand that and turn it into two separate logs that are being added together. Because multiplication can be compared to addition, just like this exponent rule over here. I know my hole punch goes through here. That would say the word log, b, log base b of m divided by n. So just like we have division here, we are able to do subtraction. That's how we are going to write this. Log base b of m minus log base b of n. So some things you might notice about how the way I write mine. Log, for me, I always use a cursive L. That avoids anyone thinking that it's I, the letter I. Whatever I'm taking the log of, I always use parentheses, but it is perfectly fine if you just write log base b of m and you don't write any parentheses there. Perfectly okay. The last one is very similar to our exponent raised to another exponent rule. Um, if we have an exponent within a log, that exponent is going to be rewritten as a coefficient. So this would be r times whatever the log base b of m would be. So exponents we know to be coefficients, and multiplying is adding, division is subtraction. So we're going to try a few of these examples. Log base 3 of 4x. We read it as 4x, but technically this is 4 times x. So multiplication is like adding. So I can rewrite this and expand the log to be 4 log base 3 of 4 plus log base 3 of x. And that would be your final answer. Number 2, very similar to the example that we have for division, we have y divided by x. ln just stands for natural log, so we would write natural log of y, and we would subtract natural log of x from it, because division is subtraction. Now these were variables, and so is this one. Over here, when we did log base 3 of 4, technically that is a value I could get in my calculator, but there's nothing 3 raised to what power equals 4. There's no thing. This is the most accurate way to represent that value. That's why we left it alone. But in the next example, if I expand this out using the division rule, so log base 4 of 64 minus log base 4 of 16, I don't have any variables here. And if I do that same property that we did yesterday, or if I individually set these equal to x and I do a little lasso, 4 to what power is 64 and 4 to what power is 16, we can easily evaluate this portion to be equal to 3 because 4 to the third power is 64. And we can evaluate this portion to equal a 2, okay, this portion, because 4 squared is 16. And since now we did subtraction, 3 minus 2 is 1. So that one I can actually get a tangible number as an answer because everything was a terms of numbers. Oh, okay. Sorry, everyone. Well, that was something. Sorry if that hurt your ears and you had earbuds in. So in number 4, there's a lot more happening in here. So technically this would be 3 times x squared times y to the 5th. So I'm going to do this one line at a time. If I was to expand that, since there are 3 separate items inside of our log, we should be writing log 3 times. Log of 3 plus, because we associate multiplying with adding now, log of x squared plus log of y to the fifth. Now, this isn't our final answer because there's that last rule where if we have an exponent within a log, those have to pop out front and become a coefficient on those individual logs. So our final answer here would be log of 3 plus 2 log of x plus 5 log of y. That would be our final answer. Okay, number 5. This one can technically, with this square root, be rewritten as natural log of x to the 7th, y to the 3rd, and then that whole thing is to the 1/2. Because earlier this year we learned that fractional exponents, 1/2, is the same way to write radicals. So a 1/2 is a square root. So this has multiple layers to it. First, this becomes our coefficient in front of the overall log. So again, I'm going to do this in multiple steps. 1/2 natural log of x to the 7th, y to the 3rd. Now, we still have multiplication happening within the parentheses. So that means I have to turn that into 2 separate logs. So now, 1/2, start a parenthesis, natural log of x to the 7th plus natural log of y to the 3rd. All right, and now within there, this 7 is going to jump out in front of its own personal log, and then this 3 is going to jump out in front of its own personal log. So we end up with 1/2 7 natural log of x plus 3 natural log of y, close your parentheses. Again, you don't need the parentheses around the x, and you don't need the parentheses around the y. I just like to write it that way, and you do not have to. Now, I would accept this as a final answer. But if you would prefer to take this 1/2 and distribute that to the 7 and the 3 and write it as 7/2 natural log of x and 3/2 natural log of y, that's fine too. Both of those answers are equivalent and I would accept either one. All right, let's just do one more here so then we can go to the other method. So if we take a look at number 6, we have natural log of a times b, both of those things being squared, divided by just c. So maybe my first rewrite would be to deal with this division. And again, once you start getting the hang of these, you can start skipping some of these steps. I'm showing you every single step, but if you get the hang of it, you do not have to show every single step. So first line of defense, maybe I would write natural log of AB squared minus natural log of C, because division is subtraction. So get that out of the way. Now, what I notice is maybe I would write this 2 out front. So maybe that would be my next step. And again, if you're able to jump right to the final answer and you can dissect it that quickly, that's great. Last but not least, I have an a times b in here, so I need to separate those. So since this exponent is surrounding the a and the b, then this too is going to be a coefficient on the natural log for the a and the natural log for the b, subtracting the natural log. So that would be our final. All right, let's take a look at the inverse. So if they are already expanded and we want to put them in contracted form, so you might see the word condensed or contracted. Again, they have to have the same base, okay, as long as they're the same base. And what we want to do is combine. So if we see the word log written twice, and they're connected with a plus sign, then it's literally the reverse of what we just did on the last page. If we see a plus sign between 2 logs, we're going to put them together and use multiplication. If we see a subtraction sign between 2 logs, we're going to do division. And if we see a coefficient and we are trying to condense the log, make it tighter, log base b, that would be of m to the r power. Okay, so it's literally the same rules, just in the reverse order. So what I notice in number 1, I see a big subtraction sign, ln is written twice, natural log is written twice, I need to write it once, and then it will be of 8 divided by y. Now for these, since we're condensing, you should use parentheses like I am, okay? Number 2, I noticed that this log x has a coefficient of 2, this log y has a coefficient of 3, so those have to pop up and become exponents. So if you're not able to do it all in one step, it's okay. Take your time and write it out. Okay, so all I did was I moved my exponents up, and now this plus sign tells me I'm going to do multiplication. A common mistake is people like to write the word log multiple times. When you are condensing, you should write the word log only once. So it's log of all the things. So in this case, x squared y cubed. Number 3, we have this 1/3 that has to pop up on the 8. So we have natural log of 8 to the 1/3 plus natural log of x. And then you can kind of ask yourself, sort of like the last page, we said 1/2 was a square root. Well, 1/3 is a cube root. Natural log of the cube root of 8. And I realize I probably could have written that in the margin, but we should know what the cube root of 8 is. That is just natural log of 2 plus natural log of x. Plus is multiply, so this would be natural log of 2x. Notice all of these have the same base because we're trying to practice these rules. I would say 99% of the time, they're going to have the same base, but I'm asking you to expand or condense. Let's do one of these crazy looking ones. Let's do number 4. We have lots of space, so I'm going to do number 4. Take it one step at a time. I know this 1/2 is going to impact just its log, so just x. This 2 should impact only its x, or I'm sorry, its y. So only that. So you know what? Let's just write that. Log base 4 of x to the 1/2 minus parentheses log base 4 of y squared plus log base 4 of z. Now I am noticing a bunch of parentheses in this question that are occurring after a subtraction sign, which means all of this must be my denominator. This is a 4. All of our bases are 4. So that must be my entire denominator occurring after the subtraction sign. So let's condense this part first. Plus means to multiply. This whole thing would condense to log base 4 of y squared z. That, and again, this pesky 1/2 is back again. That's the radical x. We know that's a square root. And so I condensed my denominator. This square root's going to be my numerator. Here's subtraction, so we'll write the word log only once of the top divided by the bottom. You do not have to write the word log more than one time when you're condensing. So that would be your final answer. At the bottom of the page, it says given log base 2 of x is a and log base 2 of y is b, rewrite the following in terms of a and b. I'm probably only going to do maybe 2 or 3 of these. All right, first of all, I noticed that multiplication is happening. So if I were to expand, I would get log base 2 of x plus log base 2 of y. In the problem, they're telling me log base 2 of x is a. So this is a, and log base 2 of y is b. So if I wanted to rewrite in terms of a's and b's, I would say that this is equivalent to a plus b. So let's try another one. We'll do 2, and then we'll also do number 4. All right. Log base 2 of 4x. That is really 4 times x. So if I was to expand that, that would be log base 2 of 4 plus log base 2 of x. This is what we did yesterday. You could set it equal to x. You could lasso it up if you want, or you could ask yourself 2 to the what power is 4. So overall, this has a value of 2. 2 squared is 4. Plus log base 2 of x. This is one of our givens in the problem. So this is equivalent to a. So in terms of a, in this case, it would be 2 plus a. All right, last but not least, log base 2, well, last but not least on this page, log base 2 of y to the third. So let's separate by division. So log base 2 of y cubed, and then we subtract log, no, break up, please stop. That's my dog. Break up. This 3 is going to pop out front. I'm sorry, it's hurting your ears. Log base 2 of y minus log base 2 of x. Come here. So that 3 pops out front. This is part of what was given right here. That's b. We have 3b, and then this was given as a. It would be 3b minus a if I rewrite it in terms of a's and b's. All right, the last little bit you're going to want, well, I guess I'm getting ahead of myself, but flip it over. We're doing the same sort of concept here at the top of the page, but instead of trying to rewrite it in terms of a's and b's, we are trying to rewrite it so that we can find the log of 2. So if I think of 20 to be broken down into 2 and something else, hopefully you would think, oh, well, 2 times 10 is 20. And since we have a rule for multiplication, I could break this apart to be log of 2 plus log of 10. Now, yesterday we talked about if there is no base written and it's a log, not a natural log, but a log, the invisible base is 10. So in your calculator, if there is no base written, on the left-hand side, there's a button that literally says the word log. And that is that's the common base. That is common base log 10. So there's log. Log of 10 is 1. And that's because whenever the base matches whatever you're taking the log of, it will be equivalent to 1. So this would be plus 1. The log goes away because we just found that log base 10 of 10 is 1. In the problem, I'm giving you an approximation for log of 2 because that's not an exact value, okay? And so the problem's telling us to approximate it as 0.3010. And so if I added those together, it would be 1.3010. So it's just really an approximation is all we're doing for that top section. Nothing too worrisome, I promise you. So how do I type a log in if it's not a base 10? Where do I find that in my calculator? So evaluate log base 6 for 5. Back in my day when I was an old lady, or sorry, when I was a young lady, I'm an old lady now, I would have to type this in my calculator using that log button, and I would have to do log of 5 divided by log of 6 just to get this change of base. You guys are so lucky now because there is a button in your calculator that lets you type it in just straight up. So in your calculator, if you go to the math button, and then you're going to press this green button above it, and then you're going to press math again. Math, alpha math, will get you that common base. Now, where am I actually coming from? If you go to math, scroll arrow up. Use the arrow key and go up, up. And it says log base. Choice A is log base. And yes, I know it's right above it. You know, holding out on you. But log base, if you go to that, you can type in a 6 and a 5. And it's the exact same thing as I unfortunately used to have to do back in my old days. Log of 5 divided by log of 6. So I used to have to type them in. And you get the same answer either way. So this would be approximately 0.89824, dot, 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 dot. So if you want to practice number 2, math, alpha, math, log base 2 of 10.4, hit enter, and it would be approximately, oh, it's a safe for decimal place. There you go. Okay. The bottom section here, guys, is just a matching Not super important. It's just the rules. If you remember how to condense them or contract them or expand them, and it's a multiple. I'm going to end the video here. Hopefully this helps, and I'll see you next time.